Alright, so this question, it gives you a function and also it gives you directional derivative of function at 0, 0 in two directions and asks you to find gradients. So this question is a little weird because usually they give you gradient and ask you to find directional derivative, but this thing asks you another way around. So first of all, let's look at the formula for directional derivative. So directional derivative at this direction of the function at 0, 0 is nothing but the vector itself dot with the gradient. Right, and this is something that we want to find. Okay, so let's suppose the gradient at 0, 0 is AB. Then we have this guy is 1/5 equal to 3/5, 4/5 dot with vector AB, right, which gives us 1/5 equal to 3A/5 plus 4B/5. So that's what we get from the first equation. And then we can do the same thing for the second equation. So if you try the same strategy on this one, you get 17/5 equal to 3A/5 minus 4B/5. So, but what you want to keep in mind is the end goal is A and B. You want to solve for A and B. And you have these two equations. So it's just a system of equations and solve for A and B. So you look at these two and you see you have 4B/5 here minus 4B/5 here. If you add these two equations, then you will be able to solve for A. So let's call this guy 1. Let's call this guy 2. And if you add 1 to 2, then what you get is 18/5 equal to 6/8/5. Cancel, cancel, A will be equal to 3. And once we get A equal to 3, then we can solve for B. Let's see. We can plug into either equation. They should give you the same answer. Let's plug into 1. So 1/5 equal to 3 times 3/5 plus 4B/5. 1 5 through, get 1 equal to 3 times 3 is 9, equal to 4B, plus 4B. B equal to 1 minus 9/4, so that's minus 2. Right, so with all those calculations, we get the gradient at 0, 0 is AB, which is 3 minus 2. Alright, so that's part A. Part B asks you to find a tangent plane at 0, 0, given that the function value is 1. Okay, let's move on to part B. Part B asks you to find tangent plane at 0, 0, given that the function value is 1. So let's recall the formula for the tangent plane. So tangent plane at x0, y0 look like z equal to f evaluated at x0, y0 plus partial x at the same point times x minus x0 times partial y minus y0. Okay, in this case, x0 equal to y0 equal to 0 because we want point at 0, 0. And in this equation, we know everything. Well, you might wonder how do we get fx and fy? Well, that's part A. Simply because the gradient of f at 0, 0 is partial x at 0, 0, partial y at 0, 0. Right? And we know from part A that is 3 minus 2, or 2 minus 3, I forgot.
Oh,
3 minus 2. 3 minus 2. 3 minus 2 equal to fx 0, 0, fy 0, 0. Therefore, fx 0, 0 is 3, fy 0, 0 is minus 2, and therefore you know everything, that equation. Z will be 1 plus 3x minus 0 minus 2y minus 0, or you can simplify it to 1 plus 3x minus 2y. If you want to write it in scalar form, you can also do it by writing as minus 3x plus 2y plus z equal to 1. Both of them are correct answer.